Hi everyone, welcome to Skilled Inspirational Academy. I'm Arjun. Today's class is Wireshark training. So this is a demo class for Wireshark, and today we are going to discuss about, deep about what TCP IP about, and we have different parameters to discuss the throughput issues and most common issues we face in the internet connection. So before walk you through those things, let me explain what is the use of Wireshark. So we probably seen now people they use Wireshark for capturing the packets, but from my standpoint, 2-3 years back when I saw Wireshark, it's full of packets and it's so confusing in where to start with and what exactly the packets is talking about. So I had hard understanding about this Wireshark. And then I did a lot of readings, and then it is just like a one capsule I'm giving you with all my readings, and put everything in on the table to make it very easy for everyone to understand and follow the Wireshark training. So that's the objective of this class. The main takeaway of this class would be once you finish this demo session, you would have solid understanding of what is TCP and what exactly what is inside the TCP packet, because we heard of a TCP, but we very few people they might peel out every TCP flags and TCP parameters. That so many parameters that maybe for few people so they may not heard about this TCP flags and TCP parameters before. So this particular class, the biggest takeaway is you would get a complete understanding of how TCP IP works with every parameters and why those parameters are used, and in the modern communication, why this TCP is so important for especially for network troubleshooting. Yeah, this is all about the biggest takeaway of this class. So once we finish this class, you will be so confident and you will understand better about TCP IP analysis. I hope everybody will start enjoying this class. So before start with, let me explain a scenario. We usually encounter this issue. Networking is the one common backbone where all the teams, they keep barking about this problem. They always complain the networking team for this any kind of performance issue. It can be a application issue as well. So people might have come from a different background, and I want to give you an overview of OSI model. So we all know the OSI model. It got 7 layers. So the core layer, what we are going to look at here is transport layer. So here works this TCP and UDP. And we all know about that. And we say TCP is TCP is connection oriented. And this is very reliable protocol. Why is that? What is the mechanism that's outstanding when compared to UDP? Why TCP is so reliable? Why people call it as so reliable connection? What is the meaning of it? So when there is a problem, generally what the network engineers, they have the maximum possibility to look around for an issue. What is the cause of an issue? How do they start with, and how they come to a conclusion that, okay, this particular problem is not with the network, it is a problem with application. So to get a complete insight about a problem, I don't think with the router CLIs and firewalls, we would see the TCP SYNAC. That's a stateful device, right? So it maintains a TCP session. That's for sure. Firewall is capable of it. But to peel out what is inside every TCP parameter, so here comes the Wireshark. So you cannot do that. So in the firewall, to the maximum, what you can do is, okay, if a connection is established between your source to destination, so you can say it is a TCP or UDP. And firewall will give you more control of, okay, this is a stateful connection. And you can see the TCP connection establishment. We call this as a TCP SYN and TCP SYNAC, right? Once these two connection established, then we can say, okay, this is an established TCP connection. So this is a maximum, control we have with firewall. But with the help of Wireshark, what we can do is, okay, what is inside the TCP packet? So it is something like you peel out every parameter in the TCP and you will see what exactly happened. If there is a slowness issue, there can be a multiple problems, right? So, but to figure out all that, the primary is very key thing here. So you cannot just blame it is because of an application. So to prove that, you have to do some basic checks, as you have to, example, you got your head-end router or your core router, customer edge router here, and you have BGP peering with your provider edge, and you got your core switch. Very simple design here. So we got a couple of PCs connected. And when the traffic is initiated from the client, so you have to check here, right? Even though your bandwidth is too good, you got your 100 Mbps link, it's a fat pipe, and you got, a good bandwidth connection that's in your office, but still people are complaining about the slowness issue. So you can check the utilization. There are many monitoring tools to do that. So one we use is SolarWinds, where we can find the utilization of a particular link. So you can see this internet link is choked, and how to find all that, right? So to prevent this, in most of the enterprise design, what they do, they use QoS techniques. So we'll see where exactly the QoS marking happens and how we can find out in Wireshark. But I'm just giving an overview about QoS. QoS is quality of service. That is something like you are prioritizing your traffic. So maybe few people, they may heard of this, but again, the quick overview is inside the IP header, you can do a marking. That is something called as IP precedence value. That is, you are prioritizing the traffic. That's the main objective. So you are marking your traffic. So if from the switch level, if you do QoS, that should be visible under the layer 2. So what is the quality of service you are using and how you are prioritizing your traffic? Example, you are prioritizing your traffic, something like this. You're prioritizing your voice, and you are prioritizing your data traffic. This is just an overview. This is not much with networking. We'll look deeper inside the Wireshark. So I want to give a glimpse about all this. So I'll mark the packets and I'll give a priority for it. For example, for priority, I'm giving a priority 10, and for data, I'm giving priority 5, because voice traffic is very crucial and it is vital for the network. So people should not be disconnected when they are on phones, when they are using their Teams. So the priority is higher for voice. So you can peel out all your QoS information inside the Wireshark, and you can see, even though if you applied a specific policy to this switch, this L2 switch, but still, if you can see from the Wireshark, if you take a capture from your PC, and if you do a packet for capture from the switch, and if you offload all your traffic back to the client PC, you will come to know whether the traffic is actually, all your packets are being marked with your QoS marking that's exactly configured on your switch, that's been applied to the specific interface. So you'll get all that kind of deep insights about that using the Wireshark. Okay, that's fine. So now I did my basic checks, something like I checked my internet link and the utilization levels, right? It can be either from your switch, or it can be from your WAN. That is the only possibility, right? So if you got your router, something like this, and it is connected to a switch, and you got your PCs connected here, so it could be either this end or this end or this end, right? So because this is connected to ISP, you'll check all these 3 ends, and you'll look for interface errors, utilization levels, right? If there is any errors, there's something like a physical issue, you will see the CRC errors keep increasing. And if you see any kind of utilization here, it's your bandwidth is choking for 75%. You'll get to know about all this with your monitoring tool. That's fine. So I have checked everything. Now the scenario is I have checked every single possibilities what I have, but I couldn't figure out where the problem is. So now I am concluded that, okay, all my layer, all this below 3 layers, my physical layer is good. My data link layer is good. My switches actually forwarding all the frames. That's no problem with the switches. And my network layer is also clean. There is the utilization is quite normal, and there is no CPU utilization on my router or no CPU utilization on my switch as well as my PCs, right? So all the basic checks you have to do. That is very important because network is just like an highway. So if there is a congestion here, then apparently your application will be dropped. Agree? So that's how it works. So my highway is clean, my cabling is fine, my switch is fine, my router is fine, utilization is fine. There is no problem from the network perspective at all. But how do you say, or how do you convince? I would say it is a convincing. How do you prove exactly that, okay, this is not my networking issue? That's a problem, right? Because people, they say, okay, if all good, then why still my connection is bad? Why I'm dropping my packets? Why the communication is not so healthy and faster? So it's pretty slow. So this all the application slowness, generally the people, they complain about this. So how do I overcome this problem? To know about that, I have to give an overview again about the TCP. So it is not that if I send a packet from one source to destination, I'm not pushing the packets without any mechanism. So how I know, how I can guarantee all the packets has been delivered to the destination? How I can be confident enough for about this packet delivery process? So to rule out this issue, they have a protocol called TCP. That is called Transmission Control Protocol, we say. But what exactly it does? So for every packet, it has its own database. It's something like it make note of every packet that it sends. So how this mechanism exactly works? Yeah, this is how the TCP parameters helps us. So if I got a big data, so one big data example, it is a 64 bytes data, but I cannot send us a one single packet. So I'm going to chunk this packet into small sizes. So for every packet, I'm going to identify every packet using the sequence number. Why it is used, I'll show you there, but I'll give you again an overview about that. So sequence number. With the help of sequence number, I can track every single packet that's been sent from my source. Example, this is a sequence number 1, and I'm going to send the second packet here. So my second packet is something like the sequence number 2. Just for the demonstration purpose, the real sequence number is different. So this is the sequence number. And before that, actually, if you do a capture using the Wireshark and any analyzing tool, but one key thing you should understand about this Wireshark will use a sequence number called as relative sequence number. Why this is used? Relative sequence number is for the administration is very simple. Example, if you use your raw sequence number, it's very hard to follow the packets. But if you use a relative sequence number, that is something it gives more control. You can actually track down. That something starts similar to 211, and it's an increment of 1, 213, 214. 2 and 5, something like that. So it is a sequential approach. It gives more control to track down your packets, how many packets has been sent and received. The raw sequence number, I mean, it's again a very big challenge for us to track the packet. So to make it simpler for the tracking purpose, they have introduced the relative sequence number option in the Wireshark, where if you want, you can enable it. And I would hardly suggest you to always keep it enabling the relative sequence number. So Wireshark displays a relative sequence number by default. In reality, the initial sequence number is 0, and it can be anything between 0 to this many values. It's 2 to the power of 32. That is the maximum value that it can use. So if you want, you can disable the sequence number. If you see an option here, there is a relative sequence number that's enabled by default. I hardly suggest, and everybody, they use this by default. So this is the use of relative sequence number in Wireshark. So coming back to the TCP process. So this is a quick overview about the sequence number and acknowledgement number. And when we talk about TCP is a 3-tuple connection. It's a three. Sorry for that. Let me write a little bigger here. We call this as a 3-tuple connection. Why it is called as a 3-tuple connection? So to do that, let me open up my whiteboard. Okay, so if this is example, this is a source. And this is the destination. So this is my PC here. And this is my server. It can be not my server, it can be a public server. And I'm trying to access a HTTP request. I'm going to generate a HTTP GET request here. I have opened a web browser here. And I'm initiating a HTTP GET request. So this party, if you see the OSI reference model, the application layer is a layer where exactly we got our payload. Our payload is the application layer. So how that sequentially happens. So we'll just look about, okay, application layer here. So I have opened a web browser and here works my layer 7. And what is the protocol I'm using here? It is HTTPS. We call this as an HTTPS TCP over TLS. So all the connection are secured. It's all encrypted. So the data is keep on encrypting for every layer. It keeps incrementing the in every layer it keeps encapsulating the data. So this is presentation layer. And you got your session and you got your transport layer. And we got the network layer here and we got the data link layer. This is layer 2 and this is layer 3. So my packet is keep on encapsulating, right? So visually how it looks, my packet is something like, see, from here, this is layer 7. And what is the payload? That is HTTPS. And it will be sent to the layer 6 presentation layer. All this data formats will be happening here. And then it comes to transport layer. The key things we are looking here. So inside the transport layer, so it's going to decide I'm going to use TCP or UDP. So I'm going to use TCP here. Right? Inside the TCP, you got multiple flag values. We'll discuss about that, but an overview inside the TCP. Okay, so I'm using TLS. Then in the network layer, it's going to specify the source IP and destination IP details. And finally, the layer 2, it has source MAC, destination MAC, and all this package is in a one single package. And if you look at, if you tear down this TCP packet here, actually your payload will be encapsulated, right? So my actual payload of this is an web traffic. This particular payload, it's keep appended until it reaches a TCP, and from the TCP it will check is it a TCP or UDP, and along with the payload, and it will send to the IP layer, then layer 2. So this encapsulation keep happening until it reaches a layer 2 from PC. So all signals, it doesn't understand about anything. So whole thing is a package. So it's going to push this packet back to the destination. And this is, I call this as a top-down approach from the sender, and it is a bottom-to-top approach. So it keep decapsulating, right? So my router is only interested in the IP packets. I'm not interested in layer 2. So in the same way, switches, it will just look for the MAC address. And if it needed, it will do all this, the router, it will do, okay, so this particular IP is in my network, but I don't know the MAC address. So here comes an R. So this packet is keep on encapsulated until this TCP, and it will open up, and it would see, right? And this is a peer-to-peer connection. It's an end-to-end connection. So this is about an overview of how these packets are encapsulated and decapsulated. When it comes to specific about TCP connection establishment, it comes to TCP connection establishment, this is my source and this is my destination. So I have encapsulated all the packets now. Now what happens? It will send a SYN packet. That is something like, hey, I want to establish a connection with you. Can you respond me back? But here comes the question. So inside the TCP sync, what are the information it would send? That is important, right? Okay, let's see. Now, I said this is a 3-tuple connection, and I have sent a SYN. For this SYN, it's going to say SYN ACK. For your SYN, I'm acknowledged. I'm okay to establish a connection now. For your SYN, I send a SYN ACK. So that's kind of an agreement. Okay, I am also okay to receive your traffic. So for this SYN ACK, it's going to send an ACK. And here the connection established. Until this point, no application data, no payload. So here we say it is in a ghost bytes. The sequence number, something like it is just for identity purpose. It just marks it as my sequence number is 1, and I'm sending this to you. If you got my SYN packet, you have to acknowledge this back. So it's going to say, okay, I received your packet, so I'm going to acknowledge, and my acknowledge bit is set, and it's going to send this back. So inside this TCP, if we peel out the TCP packets and parameters, so you can see what is SYN flag. If it is a SYN flag set, then it is a SYN packet. If it is a reset packet, so it is a reset set. So reset happened here. So this is how the connection establishment happens. Then comes your actual payload. So now let's see how we can see all this information with a complete visual in Wireshark. So to do that, let me open up this capture. Let me go to TCP capture. Let me take this IP of capture. So let me give TCP. So this is the filter we use in the Wireshark. So let me give you an glimpse about the options, what else we have. So all the customized template what I have created to have more insights on the fly. So this is the time when exactly the connection happened. This is the column where it defines about the time here. And this delta time we'll discuss in the class, but for the reference, delta time is very vital to understand where the problem is. So it's all mostly in milliseconds, but if it crosses the seconds, if you actually see this all milliseconds, this is 35 milliseconds, and this is 41 milliseconds. And if you see any values that's been incrementing here, that is defined as seconds. So in the networking world, everything is happening in milliseconds. If it exceeds a milliseconds, and if it's going beyond millisecond, and if it is in seconds, then there is a problem. That's a slow connection. So networking never like the packets to be in seconds always. So for the optimal performance, it has to be in the limitation of milliseconds. So that's how this delta time values used to figure out what is the time taken for the source and destination. So delta time, and one key thing I would say is we call this as a round trip time. Call this as RTT. Example, if you make a flight booking, that's something it will ask for. It's a one-way booking or it's a round trip booking. So that is something from source to destination, from destination to source. What is the time taken? That is bidirectional, from source to destination, from destination to source. How long it took? So that is actually a round trip time. We call this as an RTT. Even if in the ping request, you would see your RTT time. When you do ping, generally you can see your RTT. What is the average time taken is 7 milliseconds. That is your RTT. Your average time taken is 7 milliseconds from source to destination, back from the destination to source. That is your RTT. And then this particular field is talking about this is a layer 3, and you see all your IP packets here. So what is my source and what is my destination? This is the destination network where I'm trying to establish a connection. And this particular column will give a complete insights about what particular protocol is used by the source and destination. If you see here, it's my UDP. It can be a DNS or it can be a video streaming. That's how we can classify the packet. So here it says it's an UDP. And TCP segment length, we'll talk about that. We know, right, when we talk about this OSA model, we know about this. All in the network layer, we say it's packets. All it is IP packets. It's network layer. So from the layer 2 perspective, it's all frames. And from the transport layer, I'm going to send a packet using TCP or UDP. So this is all UDP packets, right? So that defines, it can be my DNS, it can be my video streaming. So we have to check how you will going to classify it using the port number. If you just click on this particular packet and you will drill down, you will see, okay, this is using UDP and this is a destination port is 53047. So this is not my DNS packet. This is something else. So here is your actual payload. Payload is something, your real data, right? So you will get about the insight about everything here. This is about what protocol I'm using. It will give you that. And TCP segment length. So we know in network layer, we say packets. In layer 2, we say frames. In the transport layer, we call this as a segments. Example, if I have a 1 GB file, so can I send this a one single file? Definitely not. So this 1 GB file is again chunked into multiple segments. So we call this as one segment. So for my one segment, how much maximum data I will send? That is your TCP segment length. What is the size of my segment? So, and one more thing here, the calculated window size. What is a window size? That is something like a proposal. So I'm proposing you, example, if I come down, drill down, little bit down, if you see my calculated window size. And this is very important. The maximum TCP, what is a TCP maximum segment length? It can be 14,440. And what is the calculated window size? So this is something, the proposal, it's saying that your window size never starts like this in the beginning. If you see the capture in the beginning, If you see this window sizes keep increasing. So when we establish a connection, it's not something like I'm going to, propose a biggest window size that you can send everything. So before establishing a connection, I should know what is the window size I'm proposing. So to do that, if I give TCP, and if you see number of displayed packets here, this is all my TCP packet here. Sorry for that. So this is the number of TCP packets alone I have filtered. And here I'm going to take this and I'm going to conversation filter and I'm going to TCP. So I have to do a right click on this and I'm going to conversation filter and I'm going to give TCP. So it has populated a default filter value here. This, so we got what all the information. It says as IP.address equal 192.168.0.104. That is my PC. And the destination is 117.102.109.18. This is the public IP address 186. And this is the port number used. What is my source port number? It's 53,333. So that is a randomly generated port number. This is generated by the operating system from our PC. And this is a server port 5201. So what is this particular capture? This particular capture is something I have captured this when there was a throughput issue. I had some problem. My PC had some problem with the throughput. So let's see how this window size exactly helps us to figure out the problem. Yeah, let's see that. So before that, so I want to go to the beginning, right? So where exactly my synchronization happened here. Let me little bit drill down this. This is actually the finished packet. I don't actually see this TCP flow. It takes some time. Okay, this is the information I can see here. Let me see. Conversation filter, TCP. It's a pretty big packet. I couldn't actually figure out. Okay, let me take a different capture. I want to see the SYN packet. Oh, I got stuck here. Okay, let me give TCP here. Okay, so here we go. So we got, SYN, SYNAC and ACK. It's talking about this 3 tuple connection, right? So this is from a client, this is a server, and it sends a SYN. The beginning before establishing a connection. So let's see. So if I take this particular packet here, if I open up my TCP, transmission control protocol, it says my source port number is 61918. That's my source. And this is a destination port. So from 443, I can figure out this is HTTPS. So now I come to know, okay, this is my source and this is my destination. And if I look at this IP protocol, I know this is my PC and destination is a public server. And if you see this, these are the key things we should know about, TCP. So I was talking about this sequence number. Since I'm not sending any kind of data at this point, so this is my first packet I'm going to send to this destination server. So this is the relative sequence number used by Wireshark. So this is the only value we are going to see. We are not going to see the, random sequence number here. So we are going to see this sequence number. And if you see the flags, this is what I'm talking about. So it says it's sync flag, right? So this is a sync packet, and this particular flag, it says it is sync flag. This is my sync packet. So from the server, what is the response we get from the server? If you see here, I made a filter for granular control. There I can see all the information right away here. So here, if you see, the TTL is very important. The three default TTL values are 64, 128, and 255. And here my PC it's using something 64. That is something TTL is for every hop, your TTL will be decremented, right? TTL is something for every hop. The value will be decremented. So example, this is 3 routers. So I know my internet connection, it has many BGP peering that happened in the middle that we call as an internet cloud. And I got my destination somewhere here, so it's all connected. And for every hop, the TTL will be decremented by 1. That's the logic. So here, if you see, I can definitely see the packets are routed and my routing is fine. So the sequence number is 0. And for this, the acknowledge number, what I get from the server is also 0. So what is the acknowledgement number? Actually, it looks like, so that's your actual data plus 1. That's your, acknowledgement number always. So if you see here, the server responded back with a SYNAC, and for the SYNAC, my PC has been sent a SYN request back. And if you see the calculated window size, it started with the very least value, right? The default value 65,535, and that's been increased now. So I am proposing for 65,535 bytes. But now, since I established a connection, here we go, you send your real data, your payload. Here exactly your payload happens. And why this is important, that's a question here. Why I should know about all this? Definitely, because if there is a routing problem, I can figure out from the TTL, I can figure out, okay, this is a problem with routing. Straight away, I'm going to stop this. And if I see down, if I drill down, if my TTL is not decrementing, there is something problem with routing. So now I concluded, okay, this is not a problem with routing. This is something else, right? If you come down, the same way, the TTL is keep decrementing. If you see, here is your application data, exactly your application data, is being transferred here. Your real data is transferred here. And if you keep drill down, here your application data exchanges keep happening here. So when I stop here exactly, okay, I come to know, okay, this is a TCP retransmission. And this packet is push packet. How I know about push packets? If you see the flag here for this particular packet, this push packet is set. Okay, I'll discuss about this. So the flags are very important, and mostly in my experience, and always these 3 parameters are widely used in most of the time, the TCP flags. One is, the key thing is the SYN packet, SYN flag, and then push acknowledgement fin. Believe me, these 4 are the key flags that most commonly used, and we are so much interested to know about only these 4 most of the time, I would say. So it will not go beyond that. So push is something here. I would say push is something. See, it generally happens when the connection is about to close the data transfer. So example, if you send a sequence number and if you send a SYN and you get a SYNAC back from the server, for that I'll send a acknowledgement again. So here your actual data transfer is happening, right? Here your application data happening, and for every single conversation I got an unique sequence number. And this particular application data transfer is happening between source and destination. And when it is about to set this fin flag, it's about the push. Hey, you don't worry about that. You keep receiving my data. We are going to finish this traffic. I mean, we are about to end this conversation. This is, couple of bytes that's left out from me. So I'm going to push this packet you're going to receive. And exactly here, the problem happened, right? So for the push packet, it's asking for the retransmission. Why the retransmission happens? It says, you're going to push your data, but I haven't received your traffic, what you sent before. So here comes the role of sequence number. So this particular sequence number, for that, I didn't get the data for 33026, exactly a packet before this. If you see, the calculated window size is same. And if you see, my calculated window size is not increasing, and it is asking for the retransmission. Why the window size is not suddenly it's dropped to 82,944. Earlier this is 2,62,144. That is because I'm not ready to receive your data. You might be fast enough to send your data, but I have a problem here. You have to send your data slower because I cannot process your data. So the retransmission, TCP, duplicate acknowledgement, this all happens because of throughput issues. So this is one kind of scenario where I captured. This is, if you see a lot of fast retransmission, out of order, and all this TCP errors is happening because of a throughput issue. I'm dropping your packets here. So this is the level of detail you get from Wireshark. So inside the TCP, we have different parameter. This is one quick glimpse, and I gave you what is this window size and how we rule out this window size problem, right? And I'll show you one more scenario where we had a throughput issue with a different scenario. I'll close this connection and let me open up this. Okay. So before that, let me give you insight about how exactly we should capture this throughput issue. So I would suggest that there is a tool called iPerf. It is a very most widely used tool by the network administrator to find the bandwidth. So before that, I'll give again an overview of what is bandwidth, what is throughput, what is speed. So my early, when I started a career, I had this confusion. So what people are talking about bandwidth, throughput, and speed, what exactly the key difference between all these three? And what it really matters here in Wireshark? Definitely, yes, we should know about all that here. So bandwidth example, if you got a link here and you have connected to your ISP and this is your switch, router, anything that's connected here, this is all end user PCs. So you got your 100 Mbps link, at least line connection, guaranteed bandwidth, 100 Mbps. So this particular parameter, we call this as a bandwidth. So they say it's something problem with your bandwidth, and you have some performance issue that's happening here. So how you figure out that? You have to bypass your router. I mean, what I mean about bypass is something, I should not use a router. Instead, this particular connection that's coming from the ISP, I have to connect to my laptop and I should do a capture and I should see if any retransmission is happening like before we have seen, right? Sorry for that. Let me write it clearly. So I should see if I see any kind of retransmissions. So I have to figure out that. So before that, using the iperf tool, I did a capture here, the iperf tool. So where I want to show you exactly where this window problem happened. If I come back here, this is a reset. So there is a particular filter to figure out this. If you actually see here, see, this is the fin packet where exactly my communication, successfully terminated on both ends. So when fin packet exactly happens, this is a client and this is a server. Right? So when there is a successful connection, it has to send a SYN packet, and for that SYN, it has to send a SYNAC pack, and it will send a acknowledgement for the SYNAC. This is a common scenario where this particular fax comes in here. I told you push happens before the fin, and fin is something I agree for that. I got all the data in this particular segment. I'm talking about the segment, this particular segment. I got 64 bytes. I got all the data. I am fine. I'm good to close the connection, and it's going to set this fin flag set inside TCP from the source. And the same way in the destination, it's going to send a fin packet here. It's a mutual agreement to terminate the connection, to close down the connection from the source and destination. It's something like, you are talking to your friend in the phone call and say, hey, I'm done with my conversation, let me disconnect. That's a mutual understanding between source and destination. So that's how this fin comes here. So why there is a problem with what is this packet coloring is red? Because this is a reset. Why it is a reset? I didn't get your packet. It's abruptly disconnecting a connection. So my TCP conversation is happening here. And who is doing this reset? That's a key thing you have to figure out, okay, where there is a problem with the throughput. So if you exactly see, this is my source PC and this is a destination. And here exactly, if you see, calculated window size is 0. I'm going to reset this connection. I'm not going to propose anything because I am not ready to receive anything because I didn't get the previous packet. So I'm going to reset this connection. This connection is not successful. If you see a lot of reset packets in your network, then definitely it's a problem. But the key thing is where exactly this is happening. That's important. If you see my IPv4 IP address here, this is 192.168.0.104. This is private IP and this is public IP range 152. And if you see the TCP segment length for all the reset packets, it's all 0. If you see the acknowledgements also, I'm not acknowledging your actual segment length. This is something problem. So the real data exchange is not happening at this point. So all this red priorities and this alarm signals that indicates that there is a problem. But why Wireshark is very helpful at this point, I can figure out where exactly this happened. This is what exactly I'm trying to find. See, if this is something I am proposing, I'm saying that my TCP window is full. You don't send any kind of data. If you see after this particular conversation, this is from the client to server. So here we have to see, this is very important. So if I see the client, I got 3 resets, all happened because of my PC. And along with that, this is the destination. And this is the calculated window size. And this is the sequence number. See, and this is my TCP window is full. It's saying you don't send any data. I'm not ready to receive because my TCP window is full. TCP window specified by the receiver is now completely full. You don't send any data. I'm full. So now I can figure out, okay, this is something problem with my connection. At some point, I am dropping packets, I cannot process a packet. But even though the server is ready to send the data, but I cannot send because my TCP window is full, I cannot receive any more data. This is some kind of proposal, some warning it says. So now I can go ahead and say, hey, yeah, I agree. It is something problem with my PC. I have to look into this PC. Why it can happen? Maybe this particular PC might have established multiple connections to the internet and it cannot process the packet. Right? So my particular throughput is low. What is throughput here? So when we discussed about bandwidth, I explained what is bandwidth. That is your actual link speed is your bandwidth. The throughput is something how much I get out of the bandwidth. But how I know what is the throughput I get for my PC? So if we go back, let me try to bring up the iPuff tool here. Sometimes this public iPuff tool is always busy. I have to give iPuff. So here I got my iPuff. Let me open up my iPuff here. Open path. Going to copy this path. Open in terminal. Okay, I'm on this, and if I give dir iPuff-c, and there are many iPuff servers that you can test. I'll tell you what is an iPuff server. So we'll do iPuff testing. So let me check DNS flow here. DNS. This is a place where exactly I did an iPuff for a public server. Okay, so now I'm connected. So they say you got 100 Mbps link. So here are the key things we have to understand here. So we'll see what is the throughput. Okay. See per second, what is the throughput I get here? So this is the guaranteed bandwidth. So I got 100 Mbps link, and how much I can send per PC. This particular PC can send, this particular speed for this PC. You got it, right? This is a guaranteed bandwidth, 100 Mbps, but that particular 100 Mbps is not completely given for my PC. It's a shared bandwidth. So now I have connected my computer, my TV is consuming a few bandwidth, and my mobile is consuming few bandwidth, and my laptop, and I got a guaranteed bandwidth, and this is the throughput. I can send 21.9 MB per second. So how much data I have sent here is 2.62 megabytes. And it is the interval is between every second I'm sending this data. So this is your average data sent, and this is your average throughput. And one point of time where my PC, it says, hey, my TCP window size is full. You don't send any data until I process this packet, and I'll send out a new proposal where I know I'll propose the new window size, and then after after that you can send your data back, and I'm ready to receive. So, but at this point of time, no, my window size is full. So that is the use of window size. That's why we should know about window size. So where is the problem? So here my bandwidth is fine, my transfer rate is fine, my internet is fine, but I come to know it's because of the TCP. Since my window size is full, I cannot process a packet. I'm busy with other connection, established connection. Yeah, this is about real-time scenario where we often experience this problem. That's something people they keep barking about, this throughput issues. So you can make use of iPuff, and when I did an iPuff, this is a capture I exactly did, and where exactly it said that okay, my my PC is proposed a window size. It says, hey, I am full. You don't send anything because my TCP window is full. Here you can see my calculated window size here. It is full. Yeah, that's it about the throughput issue. You have more details in the real classes. This is one scenario. We have so many interesting topics, like how we do the same for UDP traffic, and every packet. It's guaranteed you can definitely figure out where exactly the problem is. If you see here, it proves again, I got a TCP window full error again from my client. It's very visible. It's my PC. It's my PC. It's not about the bandwidth. This is something I have, many connections running. So from there, I have to drill down. What is the problem? So the problem is what is the biggest takeaway of this scenario is you can figure out exactly where the problem is. That's the root cause. And we always have problem in finding that. We don't know where is the root cause, and you're rattling around to find where exactly the problem is. The root cause is the main thing. So from there we have to dig deeper and figure out why this particular PC is proposing a TCP window size as in it says I am full, you don't send any data. Why is that? Is it my connection is too busy or my network is too busy? So I can start looking at from my PC perspective now. So I don't want to rattle around. It could be a problem with my internet link. No, it's all clean. So this is all about the throughput and a quick overview about MTU and MSS. So this is a major confusion. Many people, they have, even I had questions 4-5 years back. What is the difference between MSS and MTU? MTU is maximum transmission unit. It comes under your Ethernet header. The maximum value is 1500 bytes. Why this is important? Let's discuss about. So maximum segment size is for TCP. What is your maximum segment size? There is a limitation for it. So I'll give you a visual about how it looks like from the Wireshark perspective. Let me go to MTU. So MTU is layer 2 and it has to match. See, if you have set your MTU as 1500, if you see here, if there is an MTU mismatch, your connection is not going to happen. So you can find everything in Wireshark. How do we find an MTU mismatch? And if you see here, this MSS, maximum segment size, is on TCP. It's on TCP layer. And if you see the maximum transmission unit, 1500 bytes, and it's in the layer 2 Ethernet header. And people from networking background, they might encounter this. I mean, they would adjust the MSS value in the GRE header. So generally in the IP header, I'll give an insight. And in the IP header, right, inside the IP header, there is one more header is called GRE header. Why this is used? Because if I want because my IP packets is 20 bytes, and if I add this GRE header, it's a 2 byte and additional information, I cannot exchange this data, because my actual packet size will be incremented and it cannot be routed back. So what I'm going to do here, so I'm going to decrement my payload. How to decrement the payload? So I am giving some part of bytes to GRE header. So that's the reason you do this IP MSS adjust command in your router, and you will decrement the value something like 1260. So generally it will look something like 1460 default. So if you see this particular 1500 is the MTU, but the maximum segment length, as I said, TCP and IP header is a 20 byte each, and it consumes 24 bytes extra, and your packet cannot be routed back. So you, from your actual payload, they'll decrement this. So that's the reason the actual payloads comes here, maximum segment size, and here we have to borrow some bytes. So we are freeing up some space in the segment size, and you're going to route your traffic. And now the GRE package has been forwarded without any problem. So that is something you have to adjust your MSS segment size, your payload traffic, that should be reduced a bit from your default value, so that that particular space will be used for the GRE head. So that's it about MTU and MSS. So I'm done with my presentation. So if you let me give control, let me unmute everyone. Yeah, so you have unmute permission, and if you have any questions, you can ask questions.
Can you
now.
just make me the co-host?
Sorry?
Yeah, this is Hemu. Just make me the co-host actually.
Okay, okay.
So guys, let me tell you, this particular Wireshark training we are starting from 18th of March, and it's a like weekends batch, and your classes will happen starting from 11 a.m. to 1 p.m. IST. The fees for this training is 5,000.
And what's about duration?
So can you, Arjun, can you just take this question? How much time you need?
It's a 45 hours maximum.
It will go around 45 hours.
Yeah.
Sir, sir, can I ask a question?
Yeah, please go ahead.
Please, yeah.
सर ये इसकी ट्रेनिंग सर शाम के टाइम पे नहीं हो सकती सर, इसी तरह जिस तरह अभी ये डेमो हुआ है?
Not possible.
सर बिकॉज वी आर 5 hours ahead ना, तो आप जब स्टार्ट करते हैं सर तो यहाँ पर बिल्कुल वो होता है, अर्ली मॉर्निंग होती है. आई मीन द कोर्स इज वेरी गुड, I've gone through the content आज, तो it's very good and the fees is also very मुनासिब. लेकिन सर ये टाइम का सर इसका प्लीज अगर आप कुछ देख सकें सर तो.
Let's see, we will discuss internally and we will let you know on that. Okay, you can reach out to me directly.
No worries sir, thank you.
Thank you. Yeah.
Yeah, guys, if you have any questions, you can ask your questions.
Sir, one more question about the troubleshooting part. Sir ये जो troubleshooting होती है सर Wireshark की, सर इसके बारे में सर कोई real scenarios होंगे, जिस तरह say for example if we find a problem at work where there is like a slowness or somebody is complaining that we cannot access XYZ server, or there is a delay or something like that. So sir, would we have like some sort of scenarios or something that we can look in here and then go back and compare at work and try to fix things like that? Is it possible?
Yeah, I mean, you mean to say that's something different. I didn't get your question. Something you mean to say we have to replicate a problem and do a capture and do an analysis, so that helps you to figure out exactly where the problem is?
Sir, exactly. I can give you example. Say for example, I have a problem at work, same like you discussed that there was like a throughput issue or something like that. So would there be like any more scenarios that we can look into and compare it what we have and give them some suggestions?
Yeah, of course, you have to take a capture. It depends on your device. I mean, you can take TCP dump, or if it is a Cisco boxes, you have inbuilt embedded packet capture functionality. That is, you can make use of your device, and you can take a TCP dump, and you can offload the PCAP file to your local PC or your TFTP somewhere, and if you have your PKF file, then yeah, definitely we can look into it and we can figure out what could be the problem there.
Okay, all right, okay, sir. Okay, thank you.
No problem. Yeah.
Hi Arjun, this is Shoaib.
I show you.
Arjun, the session was, first of all, I would like to congratulate that the session was good.
Okay.
So, like you mentioned about the throughput issue from your PC, that it was not able to receive the packet, send the packet again because it has this capacity full. Okay,
Yeah.
so probably it was due to the throughput issue. So
Yeah.
similar issue I am having in a production environment where the end user is your Android APK,
Okay.
and there are multiple retransmission is being sent from the source to the destination, means from the Android APK device to the destination, which is behind the F5 firewall.
Okay. Okay.
So what would be the possible reason? I have that packet captures with me. If you can, if you allow me to share, then I can share those.
No, in the real classes we can do it, but since this is a demo and that is strictly confidential, I think
That's
we should
fine.
not
That's
do
fine.
that. Yeah.
Then fine. No
Hello.
worries.
Yeah, no problem.
Yeah, hello. Hello.
Yeah, hello. Yeah.
Sir, Manish this side. Actually, sir, I want to ask, means rather than Wireshark, actually one interview question I want to discuss with you. Is it okay, sir? Means if I ask.
Yeah, sure.
Yeah, okay. Last means 2 days ago, I had interview with TCS. So they asked me about the means if they asked me about the DHCP server. Okay, DHCP server is not in our VLAN. So what is the this scenario? Means is the client and server of the different VLAN segment can communicate. So means. So at that time I had no idea about the DHCP relay agent, how to work. So sir, please could you explain me in overview means DHCP relay agent, how it works and means what is the scenario?
Yeah, sure. So example, so generally
yeah.
In the enterprise, right? So in the enterprise, people, what they do generally, if this is your switch and they say DHCP relay agent, you have some, you have a fair idea about how this DHCP relay agent works, right? So example, this is your DHCP relay agent, and the ideology is something you might have one common DHCP server. So that is the ideology for every VLAN, for every network, and for every site. To have a DHCP server is not a good practice. I mean, I'm not saying it's a good practice. It's from the administration standpoint, it's very hard to have multiple DHCP servers when there is a problem. There is something like one common DHCP server. For the management perspective, it's pretty simple to manage and troubleshoot. So here you got your PC. Example, your PC is on 10 network, right? So what exactly happens, DHCP is a broadcast. Are you aware of it? So DHCP packet is a broadcast. So inside the local LAN, that's something inside this particular network. If it is a 10 network, it's going to broadcast to all the IPs, right? Looking for the DHCP response. But since I got the DHCP relay agent somewhere here in the data center, that can be in any subnet. Example here, let it be 15.0.0.1. Example, this is your DHCP relay agent. So if for this particular broadcast, it hits your gateway for sure, right? Because it will send to every PC. That's a broadcast. So when we get this broadcast packet, so inside this, you configured your DHCP relay server. The relay server is configured and you have given the IP address, something like 15.0.0.1 is my relay server. So what happens from the PC to the gateway, it is a broadcast.
Yes.
But whereas from the gateway to the DHCP relay agent is a unicast. So here in the unicast, what is the information it's going to send? It's going to send this gateway address. What is this gateway address? So this is my gateway address 10.0.0.1. So what happens when it goes to the DHCP server? It got multiple pools and it's going to look for this particular pool. If there is a match, it's going to look into the scope. Okay, I got an IP range from 10.0.0.2 to 10.0.0.254. So I got this many IPs and it will reply back again to this gateway, and this gateway again, it will reply back to the PC. It says, hey, here you got your for your DHCP request, I'm going to offer this packet. Offer is just kind of, it's going to say, hey, this is the IP address. If you want, you can use.
Okay, yes. Sir.
Until this point, there is no commitment that I'm going to use the same IP address, but for this DHCP request, it's going to send a DHCP reply back.
Okay.
That is
So,
offer.
yeah. Yeah. So sir, means outside the VLAN, it goes as a DHCP relay agent. Means if it is server is in different VLAN, so then yeah. So if my PC is in 10.0 network VLAN, okay, and that server is 20.0. So means from the 10.0, it will get to the gateway of the 10.0. Suppose it is 10.1, and from the 10.1 it will unicast the DHCP relay agent till the server. Is it is that flow?
No. Flow is something. It is from the gateway to the DHCP server. It's a point-to-point connection. It's a unicast, right? It's straight away to your DHCP server because you defined your IP details there in the DHCP relay. So it's a unicast straight away. It relays back to the DHCP server. So you have to understand one thing. See here, if your routing is fine, you have to check first. You have a reachability to your DHCP server. Yes, then your routing is fine. Then happens the unicast. The first overlay is your routing, and then on top of that, it's your underlay is your routing. If your routing is if your routing is properly happening and you can reach the destination, then comes this unicast packet forwarding. Yeah.
Okay.
Sorry, sir. Simply, you can just say like this: if your DHCP server somewhere in a data center which is not in the same network, and you want to get the IP, because in order to get this to the client, get to the IP address, they need to communicate with the DHCP. Yes, you're right. The communication will be there, but only the simple thing, if the DHCP IP helper command needs where your client is not in the same network. That's the, because DHCP is a layer 2, isn't it? So it's not, it will broadcast, but it will not go after broadcast if it's not in the same network. Suppose if your DHCP server sit in the somewhere in the data center, and you want to get connection, your client get to connection to the DHCP. Yes, you need a IP helper command. That's the only simple thing, isn't it?
Yeah, yes, sir. Got it.
Hello guys, so anyone have anything else? Otherwise we can just...
Yeah, hi Arjun, Kripa here this side. So first of all, thanks for the session. Your session will help if someone is planning for WCNA, it will be helpful for him.
What is the WCNA? Can you can you abbreviate what is WCNA?
Yeah, that is the Wireshark Certified Network Analyst.
Yeah, so definitely this particular course will help you for that. But like, I will not recommend you can go for this particular certification because it's not needed, right?
Yeah, that is my next.
If you are working as a network security engineer or as a network engineer, not needed at all actually.
Okay,
that's right. Yeah.
Okay.
Yeah, Arjun, I just have a question. Like, since I'm into the pure security side, so what are the things that you are going to cover when it comes to security part?
We discuss about TLS and various authentication mechanism. Are you working on TACACs? So we'll try to find what is why this TACACs request.
Okay.
Sorry, your voice is breaking. Yeah, if we'll see about in the course content, you will see all the security protocols. What are the security protocols we discussed here?
Yeah, any malware content or something that you can cover, at least some basics stuff.
DDoS attack. We have a topic to discuss about DDoS attack and how to prevent it, and how the Wireshark can be configured to find the geolocations where you can find where exactly your traffic is coming from.
Sure. Okay, thank you, Arjun.
Yeah, no problem.
Any other questions, guys? Anyone have? If like somebody interested for this particular training, and if somebody wants to enroll, these are the mentioned contact numbers. You have to reach out to us on these particular numbers. Anyone have
Hemu,
anything? Yeah, go ahead.
its timings are fixed because I actually
Timing
I
is
was
fixed actually. Yeah, timing is fixed.
uh,
Okay. 11 a.m. to 1 p.m.
yeah,
IST.
it's
Yeah,
actually
timing is fixed.
conflicting with my other training. That's why I'm just asking.
Okay, because time generally we used to keep fixed.
Yeah, because it's I was in the middle of the training. I can't stop it.
Okay.
That's why I'm just asking.
Got it.
Yeah, it's a weekend batch, right? So
Yep, it's a weekend. Okay, guys, so thanks for joining this particular demo. Take care and have a nice day ahead. Let just basically disconnect this particular meeting. Take care, guys. Bye.